Okay, so this portion of the chapter is called Properties of Liquids. If you have a highlighter, I think it's great to use. Otherwise, just underline what I tell you to focus on. Okay, you have to know the definition of the word viscosity. There's a lot of matching vocabulary on this test. It's the friction or resistance to motion that exists between molecules of a liquid. So I'm going to highlight that definition, but the question is, do you know what viscosity means? Like, what would be more viscous, water or syrup? Syrup. You get the idea. It's measuring the thickness. So it's important that you know this relationship here. As temperature increases, viscosity decreases. What that means is if you took your syrup and you stuck it in the microwave for like 20 seconds, what's going to happen to that viscosity? What's going to happen to the thickness of it? It's going to be less. That's what that means. So therefore, if you increase the temperature, you make it colder. If you stuck it in the fridge, it's going to have the opposite effect, right? So make sure you understand what the relationship is between temperature and viscosity. And I do think syrup is a good example of viscosity. Okay, surface tension. Most of you know what that means, but go ahead and know it's an imbalance of force at the surface of a liquid. Something like water at the lake when a leaf lands on top of it. It does that because of the surface tension of the water. Those water molecules are so tightly bound that it's hard for the leaf to cut through. Of course, you could cut it through easily if you pushed it down or turned it to the right angle, but otherwise, surface tension of water is pretty high. Okay, in this area, there's two definitions you need to know. Cohesion is the attraction between molecules of the same substance. That means like water molecules being attracted to water. Like when you see a drop of water and the fact, like if it was on the table and the fact it's in a sphere shape, how it's trying to stick to itself as much as possible. If it wasn't trying to stick together, it would just spread out. But water usually is going to be in big clumps, okay? So water is attracted to itself. Adhesion is the other word that you need to know. The attraction between molecules and the surface of another substance. So like if you had water in a test tube, you know about the meniscus where like the water kind of sticks to the sides of the test tube and you have to read the bottom of the meniscus? Okay? It's because that water is attracted to the test tube. That's an example of adhesion, like water attracted to the test tube. Okay, that's what I would focus on there. Moving on, fluidity is the ability to flow. Good examples would be anything that is a gas or a liquid. Can solids flow? No, they're just going to stay still. They cannot move, okay? Know that. Properties of water, it's a big list. I don't want to talk about it too much. I know you've learned it time and time again. Memorize all of them. It's good to know. You're going to be asked about them. So, water has a high boiling point. It has a high specific heat. So like our ocean will keep its temperature pretty consistent for a long time since it's a big body of water. It's hard for water to change temperatures. Like in the winter time, you know how like sometimes we'll have weather days that are 30 degrees at night and then 70 degrees during the day in the atmosphere? Well, ocean water, that would never happen. Like it just cannot change that easily. Specific heat is talking about like the heat that the water has absorbed, and it will usually hold on to that heat. Okay, it's unusual that the solid is less dense than the liquid. That's a good one to know. Okay? Water has high surface tension. We just talked about that with the lake and the leaf. It has a high heat of vaporization. You have to boil it to a very high temperature before the gases will evaporate and it will become steam. And then another pretty amazing thing about water. It's an excellent solvent. Like, it's the aqueous, it's what makes us be able to dissolve almost anything in the lab using water. So it bonds with a lot of things, which makes it very unusual. Okay, that was information about liquids. Let's talk about solids. Now, what I would like you to do here is somewhat make the connection between these words and what we have up here, okay? I want you to realize, like, the covalent network solids, which are on top here, I did it from strongest to weakest, but the covalent network solids are what we have at the bottom here. So what's going to happen as we talk about this is you're going to see the trend as it increases strength and it increases boiling point and melting point. So let's start with the metallic, meaning these are just metals. You need to know that the metallic solids, right here, the metallic, they're metals from the periodic table usually. It's very unusual. This is something that separates them from everything else. That the electrons, the valence electrons, are mobile. They're constantly moving around it. That's what makes it able to conduct electricity. So I would highlight that too. Moving down to molecular solids. Well, the big thing here is just to see the trend that now it has a low melting point, but you know, what's happening is it's going to be a gradual thing where the melting points will start to drastically increase by the time you get to the end. The ionic solids, which are, you know, up there, metal with nonmetal, usually they're opposite charge, but know that they're usually hard and brittle, usually things like sodium chloride, which is salt. They have a high melting point, and they're poor conductors of electricity. But remember the crystal lattice? Remember this? We learned about it a couple chapters back, where they're usually stuck together as crystals with all the positive and negative charges. That's what the crystal lattice looks like. I just wanted you to know what the crystal lattice was. Okay, last one. Covalent network solids. Remember, actually memorize the three examples. We use the same ones for the whole chapter. The diamonds, graphite, and sand. These are very high melting point, and this is what overall you should get from this, is that anything on the bottom of this page is the very highest boiling point and melting point. They're very hard to melt and separate, but up here it's lower. Okay? But the absolute lowest would be like dispersion forces if we went any further down the list. But these are just solids. We're just talking about